screen let's start, guys. Anyone else joining? Yes. Not? Anyway, we'll start. So yeah, this session is about the basics of blockchain. I think maybe most of you guys know this stuff, but we'll anyway go through this, and so Rusuru can start the advanced things of blockchain as the next session. Yeah. So yeah, first of all, guys, let's see what an ledger is. So basically, because like when everyone talks about blockchain, it's called a distributed ledger. So let's first look what a ledger is. So it's a collection of accounts, and it keeps track of the transactions of that account. So and basically chronologically. Yeah, that's basically that. So ledger, it could be either physical or digital. So then it comes to the e-ledgers, same thing but digital. Then then we hear the concept of public ledger. So it's basically what it means is like anyone can view data, and anyone can add data. Data as in transaction records. So now there's a bit of a problem. Like if anyone can add transactions, like think about it as like you are given the access to the your bank's database. What would you immediately do? You'll go and like change your bank balance to I don't know, whatever the amount you need. So that has to be controlled. So that so that has to be controlled. That's why we need protocols and like algorithms, consensus algorithms, and all. So before coming to that, let's talk about trustless systems. So trustless system is like it's not that it's not a system that you can't trust. It's basically a system that you can trust, because like you don't need to depend on the participant. If you think about it, like even though even though it's not like specifically mentioned, you are basically trusting the bank. Like what would happen if the bank someone from the bank changes your balance to zero? I mean, you don't know, but basically we are trusting the law, we are trusting the regulations that central bank has put. So that's why we are using banking systems, and we are put like depositing our money into the bank. So banking systems are not trustless systems, but for us to have a public ledger, it has to be a trustless system. So there'll be no third party who's controlling everything. Now like this that structuring going on, like you might get capital haircuts to your deposit. Nobody's going to like nobody can't like avoid that if the government decide to take some portion of your money. So but then again, but that the government is the only entity you can trust to impose the rules, regulations, and control the banks and everything. So but for us to have a public ledger where there's no no third party, not a single entity who's controlling the system, so it has to be a trustless system. Now let's look at the concept of blockchain. So it's also a distributed ledger, uh, and not all distributed ledgers are blockchains. So there can be multiple ways to implement this thing, but the most common and the successful way of doing this is the blockchain. Uh, as I think you guys already know, it's a linked list, like linked backward. So and blockchain can be the public, or there are private blockchains as well, like maybe Hyperledger, Ripple, and the most common public blockchains are the Bitcoin, Ethereum, and there are a lot more now. Yeah. So when it comes to public blockchains, you get now. Uh, it has to be a trustless system. So now let's figure out like what are the characteristics it should have to be that trustless system. Uh, so we naturally get these questions like, what if someone had an invalid transaction, and what if someone like delete a transaction, because like everybody has the access to it, and what if someone fake a transaction, like pretends to be someone else and like add a transaction to the ledger, and what if someone denies a transaction, like maybe like you transfer someone else money, but maybe like let's say it was linked to a criminal activity or something like that, and maybe you try like, even this happens in like real world as well, like you if you do something unlawful and you pay for that, and later it was tracked back to you might like try to deny that this was not done by me. Maybe someone working in the bank had the transaction to on behalf of you, something like that. But so uh, even in the public blockchains, you have to raise that question like, what if someone denies a transaction? So this so these are like, we can think as the main characteristic that the public blockchain should have: authenticity, uh, immutability, and immune to double spending. So that you can't basically spend, you can't spend money you don't have, and then the non-repudiation. We'll go into each of these characteristics in the next slides. So before going into that, I think you guys already know what a digital signature is. It's a like mathematical way to prove uh, that this message is from you. It's a signature, but digital. Uh, I think Manojit previously did a session about cryptography, so he explained this, but like simply, you have key pair. One is the private key, and then the other one is the public key. So you can sign the message with your private key, and you get the signature from that. And if you input the message and the signature, you can verify whether it was signed by you using using your public key. Yeah. So the authenticity, like from the four characteristics of this public blockchain, uh, authenticity is achieved by using these key pairs, private public key pairs. And the next characteristic is the immutability. Immutability means the ability to like remain unchanged. I mean, like once the transaction is recorded, it's there. I mean, for you can't tamper it. So how this is achieved on blockchain? So basically, the blocks are linked to its previous block. Uh, when this happens, like if you change something, you will have to change everything after that. I mean, like if you can't come and change something in the middle. So we'll understand that in the later slides. So it's like nearly impossible to reconstruct the chain like that after change something in the middle. So to understand that, we kind of first need to understand what hash functions are. So basically, a hash function, like it takes some input and it maps to a fixed size output. And basically, it's a one-way function. I think this was also discussed in the cryptography, right? So yeah, one-way function means like you can't like get the output and figure out what the input was. So yeah, and so this is the kind of explanation of the same thing. Uh, you have the input. So I have like included as like transaction 1, transaction 2, transaction 3, because that's what you include in blockchains, but we'll come to that later. Uh, and sorry, and if you take the hash and it will come to a fixed size data. So you link uh, each. So a block is a set of transactions. So basically, blockchain is a ledger. So ledger needs to store transactions, and the blockchain store transactions in blocks, and they chain it together using using the previous hash. I mean, like it when you are like creating a block, you have to consider the previous block's hash. That's so it get links to the previous block, and that's how the chain is made. So that's the very basic idea of it. And so that's why if you change something in the middle, now then you will have to construct everything from that point to the current situation. So that's why it's called a blockchain. And so we'll discuss about like how mining happens and everything in a bit. But before that, the other characteristic.
Yeah. Achala, can you explain a bit about how hash prevents the mutability?
Right.
Like,
Yeah. So I think we'll have to like come to the proof of work and everything.
then go back.
Yeah. No?
Okay. Okay.
So I'm just like describing the characteristics, but we are like just here like looking simply looking at what these concepts are, and then we'll with the theory we'll come back to this. So double spending is like like not allowing the same tender being spent multiple times. That means like this does not really happen on like physical money transactions, but this can happen on when it comes to cash systems or like digital currency. This can happen because it's just a database. If you do not handle the complexities well, maybe race conditions, some things like things can happen. So maybe the same amount of money can be spent for multiple things, but that has to be stopped
On
for
on physical notes also, if you print
yeah
print cash.
okay, but then that's counterfeiting, but not but that's
Is it double spending?
that
If I print money,
that's not double spending, I think.
I do.
Yeah. I think so because it's not the
Then it's
same.
okay.
For me it's okay. So basically, yeah, double spending is like basically using the same thing for same cash for different purposes, but there you are like making counterfeits. Right? That's a different concept.
Okay. By definition, it's not.
That's a problem in physical cash. You can make counterfeits. Problem here is like double spending. It's more or less the same, I think. But
Maybe
so how this is achieved on blockchain? Every node validates a transaction. So like it checks whether so so blockchain is like now I only talked about the how talked about how the transaction records are stored. Something I missed was like so this is a distributed system. So there are like multiple nodes participating, and this ledger is replicated in each and every node. So each and every node like maintains the ledger, and they sync with each other, and they that's how they keep keep it up to date. And so whenever new transactions comes to them, they validate whether it was actually from the account's owner. I mean, whether it's signed properly, and whether that account has enough money to spend this amount. And then the other one is account nonce. Like when it comes to a blockchain, there can be pending transactions. So pending transactions means like the account owner has signed in that signed and broadcast it to the network, but it still hasn't been put into one of those blocks we discussed about. So it's still in the pending state. So if it's still in the pending state, and if the same account tried to send a transaction to someone else, then if the account if the what do you call the if the transaction count was like not tracked, maybe like he can initiate two transactions at the same time for the same money, but only one only one transaction can get mined, right? Was I clear about that? So prevent that, to prevent that, there's this account nonce. To basically a transaction counter. Like if the previous, if the what do you call it? Like if you say like transaction nonce is X, then X. If transaction X is not mined yet, not included in a block yet, transaction X plus one from the same account will not be added to the block. But if you want to cancel a transaction, like you can send another transaction with the account nonce being X. So one of those transactions will be mine. Clear?
To cancel it.
Yeah, it's to basically to cancel. So let's say one account. Let's say there's a
Can't I submit one transaction to this is distributed? Can't I submit one transaction to one node and the second transaction to a node that is not connected to far away from the first node? So what would happen then? Like both will propagate in the network. Which one would now I have two transactions in the system propagating?
Yes, if that's why. So usually this account like nouns thing, I'm mostly referring to the Ethereum, but I think this should be the way in other blockchains as well. So it keeps track of like it has a transaction counter. So then if when there's a transaction that is originated from some account, so it adds that nonce value. Like account nonce value. So tracking the transaction number. So in case like the last transaction is, let's say, X, X minus 1, and the next nonce value should be X, and if X is out there, and if you try to send a new transaction to the pool saying X plus 1, it won't get mined until the X gets mined. But you can broadcast two transactions with the same account nonce, meaning X and X, but only one of those transactions will get mined. That's how you handle it. So maybe like
okay.
Is that clear?
Yeah, that's clear. Yep.
Any other questions?
Is there a relationship between the consecutive nonces?
Yes.
That's
There are two types of nonces. Like definition. The one is account nonce, and the other one is mining nonce. Mining nonce is the like random data that we put into the
okay.
hash. Yeah, I will explain it later.
Okay, account nonce is per account per transaction.
Yes, account. It's a transaction count of that particular account.
Okay.
So I'm basically referring to Ethereum. I think there should be a similar concept in the other blockchains as well.
Okay. So validators have to look at the account and then see the count.
Yes.
And they can only validate the next transaction.
So, yes. If there's a pending transaction that did not get mined and you want to send another transaction, you can like put the same nonce and put it to the pool, and if you like, you can like trick. You can trick the miners. Not trick, actually. You can incentivize miners to pick the pick whatever the transaction you want by making the reward high. Yes. Okay. Then non-repudiation. So this is the same thing. Like it's like, I mean, self-explanatory. Uh, non-repudiation means like when someone signs the transaction, they should not be able to deny it. And since we are using like this public-private key pair thing, it's obviously like you can't deny it, because it, if it's signed from your private key, it's your responsibility. I mean, like if you uh, if you take the physical scenario, like you can sign a check physically, but maybe there's someone else who is forging your signature, but that's not your fault, because that's something that he's doing, the other one is doing. But when it comes to the private key, unless you lose your private key, I mean, not lose, I mean, unless you give someone else your private key, they can't simply forge your signature. So it's totally up to you to keep the private key secure. And like, since that concept is there, you can't like deny basically a transaction that was already mine. Yeah. Now let's come to the block creating part. This is the mining part. So this is a public ledger. Now anyone can add data to the public ledger, but there has to be some regulation, like who gets to add the next block. So when it's come to a distributed system, as Lahiro reminded me, it's the leader election process. Right? Like, so if for each and every transaction, there's a for each and every block that is created, this lead election thing has to happen. Like, it's not necessarily a lead election thing, but it's the deciding factor of like who's going to add the next block. So
anyway, there's no centralized control,
yeah.
and the thing is distribute.
Yes.
There should be some way to
there should be some way to figure out who's going to add the next block. So that process is called like finding blocks and figuring out who won. That process is called basically mining. And so there can be multiple implementation of this, but mainly like what common popular thing is like the proof of work related one. So basically proof of work, so maybe I'm not clear, like I didn't explain what proof of work is, but let's think about it like there's you need to do a mathematical calculation to win this race, basically. That's clear, right? So yes, so we talked about this hash function. So now simply what happens here is like you pick a set of you pick a set of transaction from the pending transaction pool, where like different account holders has broadcast multiple transaction to the network, and miners are picking transaction from that, and they get those transactions, and then they I haven't added that part. Then they put a random piece of data to this transaction list, and then they calculate the hash of it. But there's a criteria for you to win this race. I mean, like mostly it's like how many zeros the hash should have at the beginning. So like the number of zeros, that the number varies time to time depending on the difficulty. We'll go to that concept as well. But so there's a criteria for the hash, and the challenge is to find that particular hash with using a random data, because like these details are quite it's already there. Now you have to get a different, like a hash with that meets some criteria. So for to do that, you will have to add some random data and see which data gets you the correct hash. Correct hash is like hash that meets the criteria. So that process is in proof of work called mining, and so I'll simply ask a question from you all, like now I said it's a random data that you put into this and find the correct hash, and now you once you find that, you broadcast it to the network, right? And what do you do to like prevent someone saying that, like you broadcast these nonce to the network and maybe someone can catch that nonce and say hey, I found this one, and now I am the one who found this, and broadcast it to the others. How does that how do you prevent that? Was I clear about the question?
No, first of all,
Is
is
this
proof of work clear to you?
not real?
I think you
That
have to explain.
so in proof of work, what happens is like as I said earlier, you can submit as much as transactions you like to the pending transaction pool.
So we'll take an example. So let's say we are the mind
Yeah.
people right here.
Yes.
So we have Achala,
Yes.
Lahiru, Adisha, and Jayan here.
Yes.
So we are the miners in the chain. So we are competing to get the next block. So why am I competing? Because I want to earn money by appending a block. Is that clear?
I think is that clear?
So others in the call, let's say Manojit,
No.
he wants to just send the Bitcoin to
Proceed for
Proceed.
services rendered.
So what Manojit does is he's submitting a transaction to the transaction pool. And Achala, can you?
Yeah. So Monjit submit the transaction, and let's say Senal also got services from Rusuru, so he also submit the transaction, and everybody else got services from Rusuru, and they are sending mine to Rusuru, and they have all included
So they have to obviously use a cryptocurrency because
yeah,
the services are illegal.
illegal. And so all those transactions are listed here. Yeah, something I did not tell was like there are depending on the implementation, there are like block size limits. So like data wise, so you will have to pick a set of transactions, and you will pick set of transactions, and mostly what miners do is like they pick the transactions what has the most reward for them. This reward thing we'll also discuss.
Yeah, for simplicity,
Yeah, because
let's say in our blockchain, we just have to pick 5.
pick 5. Okay, pick 5. So then you get that 5 transactions, and now that transaction, now you have pick set of transactions, and that data is fixed.
So basically, again, I take 5 transactions.
Yeah.
Achala take 5 transactions. Jan take 5. Adisha take 5. That 5 doesn't have to be the same.
Yes.
Any 5. So I'm obviously going to pick the 5 that has most rewards, because if I get to append that block, I get those rewards.
Right. Now 4 of us are like trying to find a hash that meets this criteria, but now since we have already picked the set of transactions, you need to like change data and see how we can get a hash that matches the criteria, right? So for that, what we do is like we arbitrary add the data, so random data, and like run the hash function and see whether the hash matches, and you do it like in a brute force manner, because there's no way of like predicting it, right? Because
because the hash is not reverse.
not yeah, and it's like random.
Then
So now I think that's clear. Whoever is like finding the first, I mean whoever who finds the first hash that matches the criteria wins, right? Now let's say I found that random data that's ABC. Now I have to broadcast it and tell the other nodes I have found this, and this is the random. This is the set of transaction I picked. This is the random data I found that generates the hash that matches the criteria. But my question was like, if I am like broadcasting it to the other nodes, they will pick that nodes and say, "Hey, I found this."
so basically, Achala found the correct non. Correct means
Matching nodes.
matching nons, and he's sent it to all of us. So now
To the
we
network.
have a choice. We can just accept his block and start mining the next block and start competing for the next turn,
Yes.
or just
Steal
see
one.
him, yeah, steal his nons. So I get nons, and before Achala gets to others, I send my nons to them.
Yeah. How it's? I mean, it's not like that. It's not happening. But I'm asking like, can you guys tell me why it's not like that? You can't steal that nodes. Bit correct.
Yeah, sending the hash one.
Hmm.
That's the.
Oh no, hash is no. But you have to prove it.
Uh,
You have to send the nonce
so-
as
so-
well. So simply now miners get a reward as well, and maybe I mean I just asked like how we can prevent that. So what Jan said is partially correct. Like you can sign and like put that data into the block as well, and mostly like when miners I think I didn't really mention that miners when they mine the block they get a reward as well. Now that reward is also a transaction, right? So you have to include that as well. So you when you mine the block you put that transaction as well and you find the nonce. So even if Lahiru try to steal my nonce, but it doesn't matter because what that reward transaction is to me in that particular block
Alright, because your account
is the one
number
who's
is
included, and I'm the one who's getting the reward anyway. So it doesn't
Ah.
matter. So
so
It's also a transaction.
it's a transaction.
So we said we pick 5 transactions. You simply pick 4
Four
and,
and
include
one.
your
So,
transaction.
yeah.
So that transaction. So I'm the receiver.
Yeah.
Who's the sender?
So that could be a bit tricky. I mean, like there's a way to put that data into the block. I mean, that's
That's the implementation.
implementation thing.
Okay.
It's coming from 000 address when it's in Ethereum. So yeah, just a simple question that randomly came to my mind, and yeah. So maybe like we wasted a lot of time there. So we were here, and yeah, who gets to mine? I guess it's clear. So this whole thing, like deciding who created the block and appending it, and the other thing, like maybe it's not stealing from someone else, but this hash function thing, this nonce, it doesn't have an exact answer. So it could maybe like two of us find this answer. I mean the matching hash.
So
So
there could be multiple nonsense
that matches the
matches
criteria.
the hash criteria.
So since that's the case, whenever you find it, you broadcast it, and whenever like the other miner find it, they broadcast it. But whatever that reaches the network fast, I mean, like it has to propagate throughout the network. But because all the nodes are keeping a copy of the ledger, so the sooner your block get broadcast through the network, the more chance your block get mined, right? So and there are like different implementation where you are being rewarded for like finding hash, even finding the correct finding a correct nonce, even though your block is not the one in the main chain. Like in Ethereum, there's a concept called uncles. That's called that. It's like branches in the same chain that strengthens the chain as well. Like if there's attack, it has to replicate that everything. So we'll come to these attacks. We'll discuss that in the attacks slides. So yeah, it's okay. Look, and consensus algorithm. So this whole, I mean, this protocol that we use to agree on blocks, it's called the consensus algorithm, and the proof of work thing is the one that we just discussed. Yeah, I don't think we need to go through this now. So yeah, that's mainly like how blockchain works. So widely adopted public blockchains, like you have Bitcoin, Ethereum, and there are a lot more now. Yeah, I actually honestly don't know what are the main streams are, like Stella and everything. So oh yeah, so lots of. So yeah, now when it comes to blockchain, we like we get to hear this word, this thing. We get to hear about this thing as well a lot. Smart contracts. So smart contracts, they are like simply piece of programs that sits on the blockchain. Like basically, uh, the smart contracts keep the logic. Uh, they keep the logic like the function. They have functions, so they keep the logic of like changing the storage of the chain. I mean, like those are also like, if you want, like think about it like this, there's a storage there and you want to change something, you do it through a transaction. That's what basically happens in smart contracts. And so it has all the properties of this blockchain, because like it's inside the blockchain. So there you don't need to trust anyone to execute these logics. You just simply send transaction and let it execute, uh, and everyone, like all the nodes validates it. So I forgot to like mention that. So Bitcoin is like mainly cryptocurrency focused one, but it also has some capability to like program like up to some level. So Ethereum is the most I think advanced uh, public blockchain, where like you let you like program any logic. I mean, like the Solidity, the language that they use to write smart contract is Turing complete, so you can basically write any logic. And with smart contracts, like the concept dApps come. dApps means like decentralized apps, and underline you have smart contracts, and you have like a client to call the smart contract. So these clients can also be deployed in like distributed systems like IPFS. So it's like a fully decentralized distributed net, and it's like no one like there'll be no single point failure, and like no one can't take it down basically. Yeah. So let's talk about attacks. So 51% attack is the most common. So I haven't mentioned here like there are like other attacks. I mean like code. I mean phishing attacks. Like you can steal someone else private key and like pretend to be someone else, and maybe like re-entrance attack. Like since like blockchains now allow people to program smart contracts. Now those are like programming languages. Like as every programming language and as every program has, those has bugs, and people exploit those bugs, and those are also those bugs. I mean those loopholes. Those things can also be like exploited, and you can attack. Like this DAO hack happened in like 2016, where like several millions were stolen. But there are like for those kind of attacks, like you can fight back, because there was a hard fork from Ethereum network, where like people who did not agree to that, they started a different chain. Like they started different blockchain from. I mean like they started mining without that attackers data, but the other who did not agree, they went on separately with the attack.
The attack is the main one.
No, it's a classic Ethereum classic one. The main one is without the
Without
attack.
that.
Yeah, but this 51% attack and the selfish mining things, those are like, I mean, you can't avoid those ones. Like those are inherently they are in the concepts, blockchain concepts.
So the previous ones are not blockchain specific.
Specific ones, like those are like maybe social engineering things, and other ones are bugs that you see. But there's a solution for that as well. Like if everyone agrees, you can hard fork it and like go. But this 51% attack is fundamentally there. Like if you can like have more power than all the other networks, all the other nodes in the network, then it's you who get to decide. Like you can basically start mining your thing, and like you can see on transaction and everything. So it's basically gone. It's their chain. So yeah, 51%. I think it's clear. So selfish mining is like what they do is like set of miners get together, and they they try to like mine blocks, but they don't broadcast it, and they keep building on that. And when a moment comes where the main chain is shorter than their secret chain, they publicize it, and then it becomes the main chain. But obviously, you get the question, like if it's a set of miners, how can they outperform the main chain, right? So there have been like calculations done, like I guess like 22% to 25% around. Like if you have the control of the network up to 22% around, like that, you can keep like mining without broadcasting it. And also when you get someone else like transaction, I mean like blocks, you don't broadcast it to other peers as well.
Okay.
So it basically,
And you don't append those into
your
secret chain.
Yeah, your secret chain. So that in that way you can go up. You can there's a possibility of like building a secret chain, and then they suddenly publicize it. Then so all those red blocks, those were mined by the only the that set of pool. So
Basically, you trick others to believe that this is the longest chain.
Yes, because what happens is like you. Oh yeah, I think I didn't mention that in proof of work, what you accept is the longest chain. Like because there can, as we discussed, there are multiple nodes. You have to broadcast it, and from one node to reach something to other node, there can be delays. But at the end of the day, what you accept is the longest chain that is according to the rules of the public blockchain, right? So you can keep secretly mining a block from one point, and you keep mining it, and you in addition you don't broadcast it. In addition to that, you don't broadcast whatever you get from the other side of the network to the other side as well. So you keep you are slowing them down, and you are building a separate chain, and you publish your one when you get to know that the main chain is shorter than what you have now. So then they get all the rewards up to that point. And this kind of like discourage, I mean, like miners don't want to work for free. Like if this keeps happening, like people get to like take their nodes out of the chain, and eventually they might get the control of the chain as well.
Ideally, they'll have to be dispersed across the, like physically they'll have to
Yeah. So they can block everything, but there are calculations that has been done. Like you can done using this 22%, but maybe like that number comes depending on the location as well. But I don't actually know the much into the detail, but that's the idea. Mm, yeah, that's it. Anyone has questions? Maybe I missed some concepts here and there because like it some things you feel like it's obvious, but it's not. Maybe like if some things are not connecting, just ask so we can have it. We can get everything resolved right now.
Machan, proof of work consumes more energy, than other consensus mechanisms
Yeah,
like
correct.
proof of stake and other history.
Correct. There are
So,
yeah, go ahead.
so why don't we opt for those mechanisms?
Yeah. I am not promoting the proof of work thing. This is enough.
Yes.
Yeah. Yes, sir, you are absolutely correct. Proof of work is not the only thing, only implementation out there. There are like proof of stake, proof of history, as Senal mentioned, proof of authority. But main the like classic example that we take is the proof of work thing to understand this one, and also like these other. I'm actually not up to date about the other consensus algorithms, but they had issues like getting all those characteristics we talked about. Uh,
those are not
really mature,
practical to
uh,
implement. Yeah.
implement, but they are like researching on that. I mean, like there might be different concepts out there other than what we had like 2-3 years back. But what Senal said was correct.
Is he asking why that is expensive? Oh,
Senal, you just mentioned, right? Did you have a question?
Yeah, just mentioned viewers.
Oh.
There are no. So Ethereum also opted for other things like proof of
Yeah.
stake.
They are also trying to
Yeah.
like move into the proof of stake as well. Yes.
Oh,
Anything else?
so not on the theory, just on the practical side. Let's say I want to get started on Ethereum. Just I know I have a fairly good theoretical background. I just want to get started on Ethereum. How would you recommend going about it?
Basically, check open in now, like they have all the guidelines and everything, but like you can simply
What is OpenSep?
open sapling is like implementation of like standard contracts and all, like this ERC 721. There are like different standards.
Okay.
So the OpenZeppelin has like boilerplate code for that, and also they have like examples, guidelines, and everything. But even if you like check Solidity documentation from Ethereum themselves, like you can simply go to this Remix online editor, and there they have this JavaScript simulator as well. Like you don't need to really connect to a blockchain as well. They run it in the browser, and you can get the experience.
Okay.
Of,
So I can go to Solidity documentation
and yeah,
and get started.
yeah, quick start, and you just it's everything is now like there. Even from the example, so you can just get a piece of code and first run it for yourself and like see how function works and all, like without writing a piece of any like single code. And um, I mean, Manojit can explain on like how to do stuff with Solana, right?
Oh, zero.
Or Rusiru will anyway be doing the next section also. Manojit, you want to add something about Solana? Manojit didn't know.
How did it go?
Oh, then no. Anything else, guys? Also, if you want to really understand what the proof of work concepts and all, like maybe now since Ethereum has adapted the proof of stake as well up to some extent, I think it's easy for you to like read the white paper and there's this thing called yellow paper. There's a paper with like all the mathematical explanation, but then there's this simplified version like explaining things simply in English as well, so you can just check the yellow paper, white paper, and
Yellow paper is the simplified thing.
that I can't remember. check
One of this.
one of those. So yeah, you can go through the concepts. I mean, if you find the previous versions, you can see how proof of work was. I mean, like how it was, how the consensus algorithm was before, and all. I'm not sure. Maybe they should be updating it as since they are like changing the consensus algorithm. Yeah, that's basically it.
Yeah, with it.
Yeah.
Rusiru, why are you speaking on behalf of with it? Spokesperson.
We're not done. He was really asking about it. We did want to know about consensus algorithms. What exactly we did want to know?
No, I just want to know what is the concept of consensus algorithm in blockchain?
Consensus is the consensus algorithm is the one that decides like which like how do you validate the block, how do you decide like which one is the correct, like which one is the main chain now, which one is the long chain, like it basically it's basically the agreement between all the nodes of how to run the chain, right?
Yeah, sure.
Did I answer your question?
Yeah, sure. Yeah. Thank you.
Oh,
Basically, proof of work is one of the.
yeah, proof of work, what we discussed is one of the consensus algorithms, but there are more consensus algorithms out there like proof of stake, proof of authority, so and so. Yeah.
Thank you.
No.
Thank you.
Anything else, guys? So that's it.
Yeah.
Okay. Yeah, if you guys have any questions, like you can just ask on this like channel as well. But yeah, thanks for joining. Have a good evening. Okay, see you guys. Bye.
Mm-hmm.